my name is Nandini. I'm an architect, hospital planner architect with HOSMAC India Private Limited. This webinar is for the Glass Academy in awareness of World Hepatitis Day. And we are going to be today talking about how to design hospitals. So in front of you, we are going to be sharing the PPT which sequentially takes you through steps of hospital planning. So first of all, our emphasis should be ideally to understand the site, which means that we have to get acclimatized to see how the site is behaving and is going to accommodate our building for the next good 50 years. So the annual site conditions with respect to weather need to be taken into account, one. Second is the soil condition of the land. We need to do soil testing to understand what is the kind of soil bearing capacity or how deep we can go. Is it a rocky land? All these studies come through soil surveys, land surveys. We need to get all this in place before we begin the design. We also need to keep in mind what kind of architecture is prevalent around this site. So building a hospital within the context of the site should also be our motto. So these three things plus vegetation, we need to take care of existing trees if there are. All these parameters need to come in before we start to understand the site that we have got. So when you see the PPT over here in front of you, the screen, the page, we are going to analyze the movement of the sun and what is the placement of the building, because when we understand that we are able to locate the longer length of the building towards the north side, then there is less penetration of direct sunlight, and that should be our aim, if possibly can be. So the form is able to be decided with respect to the climatic conditions. So we also need a facility mix before we start our program of designing the hospital, because we need to know how the building will sit, how many floors it will have, how it will sit with respect to the composition of the departments which are going to fit into this hospital building. Now, a healthcare building will have a lot of departments, clinical and non-clinical, administrative support areas which have to come in. So a facility mix is a program where we understand what goes into a hospital. Now for general multi-speciality or many modalities, clinical modalities coming together is probably a good mix of all clinical areas, clinical departments which come together. However, a super specialty hospital will be concentrating on one typology, one clinical type. For example, a cancer hospital will be a super specialty hospital. A cardiac hospital will be considered to be a tertiary super specialty hospital. Example, Medanta, cardiac is Medanta, right? Tata is cancer. So different typologies will also aid the form of the building. So what I'm trying to say is we have to get the facility mix in. What follows from here in project conceptualization is the space program. What goes into the hospital, every room, its area, size, like a hospital can have 30 rooms to 500 rooms, but all the data, including corridors and vertical cores and the walling, the external extent with the balconies or even the elevation, everything has to be accounted in a space program. that is where one starts to walking into a hospital. Okay, so in this slide, we can see that the setback rule will be applicable, the bylaws will be applicable. We can decide how tall a building can be. That is why we have written it does go into 2 basements and a ground and a fourth, plus 4 floors. The site sun path movement we have to check. Then we can align or orient the building. So here are the licenses and approvals which we may need, from the Public Works Department, the municipalities, the Fire Department, Atomic Energy Research Board, AERB, BARC, Local Office, Ministry of Environment and Forest, MOEF, clearances. So there is a very long list of clearances which you need for this building to stand on the plot that we have received. State-wise, state-wise, these are different. So we need to inculcate or talk to the local municipal architect to get these permissions in. And once we do get these, then there is a commencement certificate. That is when you can really start construction. Again, these are the rules which will help us build the hospital. GC is ground coverage. FSI is floor space index. It is equivalent to FAR. There is no difference. This is just a difference of terminology. The RG is recreational ground. How much and what percentage of recreational ground we are supposed to leave on a site. And finally, the height of the building will determine the setbacks. The equivalent car spaces is a concept which is applicable in northern India, but not in Maharashtra. So again, like I said, state-wise, these will differ. And we have the parking norms in Maharashtra, in Bombay particularly. Let me not say Maharashtra because in Nagpur it was ECS. So parking is in Bombay. We calculate how many spaces of car parks we can provide per 100 beds, okay, in a hospital. For setbacks, there is a general rule, h/3, but like in southern India and Kerala, the h/3 is what really determines how much building you can build. There is no FSI or FAR in Kerala. So these norms one has to sieve out and see what fits as per what governs. So there are fire norms which are all India basis. And there can be a surprise sometimes if we get a site, a full site, let us say 2 acres, but along the way there is already a master plan where the road widening, the city road which abuts the site is going to take a good 6 meters of the plot because the government has decided for road widening, which means that your functional plot has lessened. So that does come as a surprise. And there are many projects that we were like told to shift the building by another 6 meters because the setback isn't right, because that part of the site has gone to the city. So it can be a little dicey, playful. So we need to, at the beginning itself, get these norms in order. So there is the balcony rule, which is applicable again in some states and not all. Refuge area is a very important rule. So it is known that 4% of the area above, let us say we do give a refuge floor at 27 meters, yeah. No, 24 meters. 24 meters we give, we allot a large refuge area to the percentage, 4% of the built-up area which is above this refuge area. 4% of that built-up area is the refuge area which is given at 24 meters if the building is tall. So this comes into play for taller buildings and is unrefutable. You have to give refuge areas. So deductions with respect to FSI are calculated by the municipal architect, and in some buildings there are no deductions. Like in Kerala, I said there wouldn't be any deductions. Everything is in the built form. Pedestrian ramp is usually at 1:12, or vehicular ramp is allowed at 1:8, but better to build at 1:10. So these are some industry know-hows which I'm giving you, which will lead you to develop, build a sound building, a hospital which will which should conform to these bylaws. So service flow is something which many architects, as well as architects sitting in the government and the municipality, do not reckon with, do not recognize the service flow. It is understood that the service floor will have a clear height of 2.4 meters from under the, from slab to slab, inclusive of the beams. One will be allowed to build a service floor, which is an uninhabitable floor at 2.4 meters only. 2.4 meters is 8 feet, which means that under the beam, you only get a clearance of 1.8 meters from an unfinished floor level, which also does mean that you cannot live in this floor. You cannot walk very well in this floor. And this is supposed to be free of FSI. It is a space where you do not account for part of the whole building. So it's out of the construction area calculations and built-up area calculations. But there are states who do not recognize this law, which means, again, that this is understood in hotel building, hospitality, but not a hospital. A healthcare building, some places, some states do not know that a healthcare building needs a service floor. So what is the function of a service floor? Let me explain to you. Usually the way hospitals are planned, the lower part of a building in a hospital is called diagnostic and therapeutic building. Diagnostic, where the diagnosis takes place of the ailments and illnesses in a person's body. And therapeutic is like the operation theaters, okay, like procedural rooms. So these two modalities, the diagnostic and therapeutic, are called D&T building. So this forms part of the podium floor, which is the lower floors. Above this comes the service floor, just one floor, and beyond the service floor, even if it's 2 floors or 10 floors, is the inpatient department, which is housing. So what I'm trying to say is there is a D&T, there is a service floor, and then on top is the inpatient housing. So the downtakes of the inpatient toilets culminate at the service floor. That is why it's called a service. It's only service oriented. You cannot bring a human over here. So the downtakes of the plumbing are routed out from the service floor to other ducts, which take the sewage out into either actually the STP is mandatory, sewage treatment plant room, or else in government hospitals, these get drained out to a septic or a sewage treatment plant outside the hospital. Some hospitals will take the STP in the basement, and some with larger plots will take it out of the hospital to another plant. Okay, so that is where water is processed, recycled, and brought back for landscaping and flushing. So STP does that. So from the service floor, this bifurcates. On the service floor, this was part of the slab, the top part of the service floor. On the service floor, we place the air handling units for HUs, for OTs. The HUs are placed on the slab of the service floor to supply clean air into the operation theaters, which are under this service floor. So service floor is the nerve center of the hospital. It is a very important element which is not recognized, free of FSI in most of the states. So what the architect is supposed to do is supposed to give a hand in justification for the service floor to be the way it is, and not to be utilized otherwise. Okay, so then there is another issue about how much will the basement be allowed. Sometimes it so happens the basement is supposed to be built only within the building line. The bylaw does not allow you to go beyond the building line. This is a restrictive clause because then we are limited to not utilizing the rest of the plot's potential. Okay, so this was in Chandigarh, we faced this. We were not allowed to go beyond the building line in Punjab. But in Bombay, you can go to the extent of 3 meters off the plot. Okay, so the building, the basement can extend out off the building line till the 3 meters off the plot line, not 3 meters off the building. So these are again bylaws which we need to be knowing. So canopy extent is also an issue. First, we used to plan with canopies 10 years ago with columns supporting RCC canopies. This is not allowed anymore. We have to have hung canopies. We do not plan with columns. Old buildings where we are refurbishing hospitals, the same thing continues. So the tread width and the riser height are also specified in the NBC. A stair tread width will always be 2 meters in a public building, in a hospital building. That is a fire norm, it's a law. And the riser height in hospitals will be 150 mm. So the riser height is what determines the floor heights. Okay, so multiples of 150 mm, 300 mm, 450 mm will always give us the floor height. So something like 4.9 meters will not do. It has to be multiples of 300, 150 mm. So 3.75 is the correct height. Will give me 3.9, it gives a 3.9. Then it goes to 4.2, okay. So hospitals need to have higher heights than residential buildings. Residential buildings are usually built in 3 meters, which is 10 feet. But 3 meters is never good for a hospital because under the slab are the, again, I would say this word, nerves of the building, okay? Electrical lines, plumbing lines, firefighting, air conditioning ducting, and also the medical gas pipelines. All these are like a network under every slab. If a hospital has 3 slabs or 20 slabs, every slab will have these networks. क्योंकि ये सारी चीजें false ceiling के पीछे छुपी रहती हैं. Okay, they are hidden behind the false ceiling, above the false ceiling. We don't see them, but they are mandatory. There are very huge red pipes, fire lines running. So a hospital floor-to-floor height is always above 3.6 meters. Because the spans of a hospital are huge, the beam is going to be deep. Flat slabs, PT slabs are not built for hospitals anymore in India. There is a national disaster code for the same. We do not build anymore. We used to build 10 years ago, 6 years ago. But in last 5 years, the code is not allowing you to build flat slabs or PT slabs for hospitals. So we go back to beam column structure. And because of beam column structure, we have to have higher floor heights. We will discuss this later. So there are regional and state bylaws which are applicable. And we must be clear what is built up area and construction area. There is a difference. There is a very major difference between built up area and construction area. Construction area is something which the builder will account for every amount of brick which is put in, plaster cement, even if it is a boundary wall or it is a parapet wall or it is a chhajja. But these are not built up area. Built up area is only what is cleared by the municipality, cleared. What is able to be constructed. So all the frills and the extras are construction area, the one where the contractor is going to build and pay. And what the client is going to build is built up area. Also, the basement, if it is used for services, it's free of built up area. It's free of FSI. So construction area, that will be counted, but not in built up area. Let's go to the next one. This is really extensive. So here is the site. You will see that the longest side of the building, which is the yellow building, is towards north. So we have tried to put inpatient rooms on that side to harness diffused light, not very harsh sunlight, but pleasant sunlight. This site was in Rajasthan, very hot. So the north side, luckily, we had the fortunate coincidence, I would say, where we could utilize the north light on a larger surface. So there is, usually in hospitals on the ground floor is the emergency. So there is an emergency separate exit and entry. There's a ramp to the basement. We have tried to limit the east and the west, and southern side we've tried to break it further and push the building in, so that the shading of the tall building onto each other surface, the other surface would allow for sunlight to be cut from the southern side. Otherwise, the building can really heat up. It's better to break the facade of the side from where the sun hits. Okay. So this is another example where we are again trying to limit the east and west. This is a second concept. And the southern side, which is actually the top, you can see the north sign. We further tried to disintegrate the building. We've tried to break the building further. Okay. So this is the one which was chosen. We proceeded with this. It's a hung canopy. And the future development we left at the back with a connection in the middle. The point of A, if you see where the A is written, that is where we would have given a connecting bridge, and a future development of another building would have come in place. Okay. This is very important. Structural grid. It takes a lot of experience to develop a grid which is favorable to hospital designs. Now again, from experience, this is coming to you that the inpatient room, which is right on top, decides the grid, always. There's no other factor. The first element which decides a hospital grid size is the inpatient room. Inpatient room is where the patient is held for the night, or nights or days. And the strength of the hospital is determined by patients who stay overnight, which means that the number of inpatients give you the size of the strength of the hospital. If a hospital, we say, has 500 beds, it only means that there are patients at the rate number of 500 who are staying in the hospital. Whichever patient is a day patient, comes in, gets chemotherapy done, dialysis done, endoscopy procedure conducted, and leaves the hospital in the evening, he doesn't get admitted, is not an inpatient. Okay? So the inpatient bay decides the grid, and as it filters down, we usually do a second check if in today's modern times, cars are able to fit into that grid, okay? Because we are going to be giving parking in the basement, and it's the same grid which will go to the basement. So the size of the grid cannot be 6.5 meters. 6.5 meters will take 2 cars. To make it more economical, we will go with 8.5 meters in today's times. Earlier we were managing with 8 meters, but one side of the grid will be 8.5 meters. The other side will vary from 8.5 to 9 meters, okay? Then after the third try of getting this grid to sit, we will go to the OT flow. We will imagine that in a grid size of 8.5 meters by 8.5 meters, are we able to fit in the OT complex in a manner which works for the systems of the complex. So from the IPD, we go down to the basement and then come to the OT. There are 3 parameters of setting the grid. There's nothing more. So it is in this system that every modality of the hospital will fit. This is very different from housing. It's also quite different from a mall setting. Okay, so now there are different styles of network: vertical transportation, horizontal movement, access to emergency areas. Do you want to give a secluded vertical elevator core to services, kitchen to laundry? So there are various styles of network which need to be weaved into this one whole building. So the ideal configuration for the room grid for a teaching hospital where we do accommodate patient beds in wards. A ward will have 30 beds. You can go with 6.5 because mostly there are no basements in teaching hospitals. These are very large hospitals of 500 to 1,000 beds, and they take mostly 30 bedder wards. Okay, so we can take a smaller grid, and which will also help us to reduce the beam. Smaller grids will have lesser beams. Then a private hospital, which is of a lesser capacity, can go with 7.5 meters, but the tertiary care hospital over here, I'm writing it is 8 by 8, I need to change that, but an international configuration is always more than 8.5 to 9 meters, okay? That really works well in our current times, and as it is time to be progressive, let's go with a grid which is conducive to hospital design. There are permutations and combinations of room typologies. There is a single room, there is a twin room, there's a deluxe room, there are suites, which are single rooms, again, but lavishly done, where a family room is combined with the main patient room. Then there are wards. So there are 10 bedder wards also, 4 beds, 6 beds, 8 beds, 10 beds, 5 beds. There are wards of different types, okay? The grid filters, like I said, from the top inpatient, it is able to accommodate radiology, which is diagnostic imaging. It's the same. There's no difference of terminology. The OTs, the OPDs, the ICUs, intensive care units, OPD is outpatient department, all are accommodated in the same way. Structural grids are accommodated in plan. So this is the same plan, which was a concept plan. Please notice that the staircases are placed in such a way that the run from any end of the hospital is being met for the fire codes. So in a sprinklered building, a building which has fire time sprinklers will have to have staircases placed at 45 meters from each other. That means a middle breaking distance of 22.5 meters is where a person should be able to run to the nearest staircase for a fire exit. So this is a meandering run. It's not the way the crow flies, okay? So this is also something which one has to take into consideration. Distance between 2 staircases is 45 meters in a sprinklered building. Now the new bylaw which has come into Mumbai, this is for the rest of India, the whole of India. The new bylaw which is working in Mumbai is that between two staircases, a walking distance, a meandering walking distance through corridors between two staircases can be 60 meters in a sprinkled, in a building with sprinklers for healthcare. So we have just done a project which is very tall, 75 meters height project, where we have gone for this by rule. Now, this again is state to state. 45 meters between two staircases, the safest, please go with that. So in this plan, you will see that the visitors core is centrally placed. It is a very good practice in all times to come for all hospitals to have MEP rooms, mechanical, electrical, plumbing, firefighting, etc. All these service rooms with vertical corridor, with vertical cores. Okay, so because we do want the shafts, plumbing shafts, fire hose cabinet shafts necessarily, corridor exhaust, smoke exhaust shafts, lift lobby pressurization, staircase pressurization, some places chiller lines, chill water lines, all these shafts to be accessible. And the best place for them to be accessed is from the main corridors, okay? The main corridors, the main horizontal spine will always be next to lifts, to vertical cores, whether it's a housing building, whether it is a mall or a commercial complex or a healthcare building. It is always a good practice to put these shafts for electrical services, plumbing services, HVAC services next to cores, vertical cores. And that is part of concept design. Architects really miss that. We shouldn't. We are conscious healthcare planners. We should get these. So this plan, if you see, there's an HE room, an electrical room next to a vertical core. So let's do that always. We are also noticing in this plan that there is a whole round circulation around the vertical cores, which is a very good thing to do because it segregates people's traffic and staff traffic at the back. Okay, so the central lift lobby is able to allow staff to move from the backside, and from the front, people and public movement is taken care of. So it also is a good practice to hide doctors and give them routes where they feel comfortable to walk around in the hospital without coming sometimes in contact with anxious families. This is also a principle which one should take home. It's good also to always put shafts next to staircases when you're planning the grid. Always remember to put mechanical, electrical, plumbing, MEP shafts in prior, and the depths always keep 1 meter. 900 mm, 1 meter depth. And the length can be 600 mm to 1200 mm. Should be on the higher side, always, okay? So this is a basement of the same plan. Between two cars, the distance is always 6 meters for cars to reverse and then leave. Again, the routes must be very clear. A symmetrical design works well. No doubt about that, because staff is then able to acclimatize with where to go, and even the public. So these zones get developed. It's always a good thing to have continuity in design as well for such complicated hospitals or buildings. So these are just departmental planning slides. The space program will also give you a stack diagram in Excel, which means to say that what goes on which floor is to be put together in a space program. Some of the modalities, let me just quickly tell you. On the ground floor, we will mostly have an MES, which is a main entrance service system, a program, where the patients and the families are welcomed, told where to go. They can sit around, there's a cafe there. There's also billing sometimes, some hospitals take billing, and the vertical core opens there, okay? Next to this MES, main entrance services, is always an emergency department, because a patient who is coming to emergency is picked up usually on the ground floor. If this is on the first floor, then we provide a vehicular ramp to go to the first floor to alight, to enable the patient to be taken into emergency straight away. It's not advisable to place emergency on the 4th or the 5th floor, and then the patient has to go through an elevator to emergency. Okay, so the emergency is on ground floor mostly. It can be in the basement if the slope of the land allows you to naturally go to the basement, to the other side of the hospital. I've seen that in Chandigarh. No? Uttarakhand? Yeah. Yeah, in Dehradun. In Dehradun, there is Fortis Hospital. The emergency is in the basement on the rear side, where the road goes down, and it is secluded from the main entrance. That is what I'm trying to say. Emergency has to have its own entrance. Just next to this, on the same floor, will mostly always be diagnostic facility, like an X-ray. You need the X-ray next to emergency, because the patient, if he has a broken limb, has to be taken into X-ray directly. So this is a good configuration. So these kind of configurations need to be built in. Now again, there is another good one is next to an OT complex. Is if you have a C-section, a maternity suite, it works well. Even if there is cath lab next to an OT on the same floor, and the patient needs to be taken for surgery, and the patient is failing during a stent operation or procedure, stent procedure, he needs to be taken into OT. So there is a direct link on the same floor. We have to take care of how we place the departments together. Now, an NICU, which is neonatal intensive care unit, is a good place to be next to a maternity suite. We all know that. So that's a whole female floor. In the same way, gastroenterology department, endoscopy, need to be given their own cohort, their own space to be in. Likewise, there's a new development in inpatient rooms also. If the whole floor can be dedicated to gastroenterology, it works well. The whole floor can be dedicated to a specialty of cancer, like the, again, head and neck. Let us say head and neck cancer can be given the whole floor, it works for them. So we are doing specialties, and especially in America and Canada, these continuities of clinical departments in inpatient work better for surgeons and doctors and physicians, etc. Even the psychiatry ward is given its own secluded area. So all this comes within the programming of the hospital and is a good feedback from client. So the architect can build on it if it has experience. If not, then the client will tell where they would want such modalities to be together. So this is how a hospital looks like beyond the false ceiling. The false ceiling is the skin. What we humans have, nerves in our whole system and our organs and our breathing lungs, is what the hospital also has. Okay. So the pipes, the drain lines are the arteries and the nerves which we have. Our lungs are like the HUs, the breathing systems, and throwing out clean air, dirty air, and taking in and throwing clean air inside. So as an architect, I take these systems to be akin to our body systems. So if we are able to apply our minds to creating hospitals as our own and seeing how beautifully we want this body to function, we will be able to understand architecture in a better way. Yeah. So I've again been speaking about all this resultant of functional space program, which is a derivation of a space program, functional program. It's an actual finite area summary. I mean, we have to bring it all together and just close it. Yeah, we do not let things fly. Otherwise, it will be unending. There has to be a synergy of departments to be put together. The adjacencies have to be worked out so there can be some staff sharing also. Then optimal operating efficiency, recognition of core and non-core programs. All this is pretty structured for a hospital. Okay, soft and hardcore clinical means there are soft services like the support services, dirty utility, clean utility, housekeeping services, HUs, all those are soft. You don't really need a doctor's degree to be there. Whereas hardcore clinical services would be the places where the physicians are, where treatments are taking place, sterility, OTs, all these are hardcore. Even inpatient is hardcore services, hardcore clinical services, okay? Requirements for expandability and adaptability is always to be taken into account because a hospital will keep changing, will keep moving from what was 10 years ago to a progressive another department, or even the equipment changes. The CT scan machine goes into greater slices of production in diagnostic form. The MRI goes into a higher equipment mode. The LINACs have changed, linear accelerators for cancer. So all this is progressive science. And we must keep in mind that the expandability and adaptability comes in when we plan a hospital for good 50 years, I mean in 75, 100 years. So this is a different way, but this is where the service flow, the interstitial flow is in every floor. The model which we were discussing earlier was a whole building. This is where every floor gets its space above the false ceiling, which means that you may have to put a slab, an RCC slab in between, or a permanent shuttering slab with RCC poured into it. But it is within 6.6 meters height. This is done at Hiranandani Hospital in Mumbai. It works very well too. However, the other system is a little more economical. So we don't now go ahead with this kind of system, but it is prevalent. It has been built. This is just a 3D image of the same one. The floor which is underneath is the usable space, and whatever is above is the service zone, and the floor above repeats the same system. Okay. But this is not in use now so much, but this always existed. This is where it evolved from. So design flexibility and modularity in the same grid is in front of you. How the same grid can accommodate twin sharing, single sharing, wardrooms, and also suite. Okay, so a suite, if you put a door in between a single wall, turns into a whole apartment kind of space. There are some patients who nowadays are opting for retreats into these suites. It is so peaceful that it's like a hotel room and your family is living next door and you're getting served and you're being taken care of, and that you really need that care. So like I said, in psychological wards, such matters do now more so come forward. So these are different kinds of locations of toilets. So this is an outboard toilet where the patient really gets pretty less natural light. The area is the same. There is an inboard toilet configuration where the patient is able to get a lot of natural light, but the toilets need to be ventilated. The mechanical systems need to work very well in this kind of setup. And then there's a central, mid, where the toilets are placed in the middle. Here again, the patient gets good natural light, but this takes more area because the amount of size which is to be given to a human's space where he's sitting, lying down, a patient is being attended, and the distance from the bed end to the wall is the same. So there is more area which one has to infuse in this system. So the best, most economical way of currently working is the inboard toilet, which is equivalent to hotels. It is the same design. Okay, now you can establish the link why hotels get the service floor and we do not get it. So this is the whole floor of the concept which I was talking about. So one thing I must say is that it is a good idea and a good planning decision to separate out visitors traffic and staff and service. Okay? If you notice, the staircases which are the rear side in this slide have 2 lifts. Those lifts function only for staff carrying carts or things in their hands or housekeeping. These dirty carts, linen carts, food carts should not come into the visitors lobby, because a visitors lobby is to be treated differently. The front entrance where you see the lift lobby written and the 4th floor plan written is the main visitors lobby. So this segregation of doctors, staff is very important from the main lobbies. Please note that. Please take care. One more thing I must tell you is that it is always a good practice to give dedicated lobbies to lifts. We should not open lifts in corridors, because when the stretcher comes out, there could be lots of people wanting to get into the lift, and that just delays movement. A good practice is to always give lift lobbies to lifts. We try to save spaces in hospitals, and we try to just push the lift back a little and give the opening of the lift onto main corridors. This doesn't work. So we should try and be considerate of our vertical movement combined in combination with horizontal. Okay, the built-up areas, the area calculation. So another thing which is a take-home for all architects is please work in Excel. It's a fantastic software. Do not work manually in your calculators. It so happens that AutoCAD, we have to do all manual work, and we can go wrong with calculations because you're working with 200 calculations, maybe more. Each floor will take so many. There are draftsmen who do that, but it is very necessary to work in an Excel. Excel is one of the best programs. So when you see a sheet in front of you, everything is calculated. You move, you change one number, and you have already summed it. It gives you the right answer. So this is just a comparison how the 2 cores, if you see the cores on the plans which are at the bottom, you will see the cores are differently put. On the right side in scheme 2 is what we were elaborating. On the left hand side is what the cores are a little more segregated. It is always good to put staircases and lifts together. Yeah, preferably do not segregate them. These are vertical transports. They're required to be together. So these are some examples of elevations. This is not a very tall hospital, the example we had taken. We can do a good amount of glazing, no problem with that. Whatever kind of fenestration the client likes, you can bring in. And the architect's design, you can go minimalistic. This is pretty heavy as well. But the client of this project wanted the elevation to be grandeur, like all glass. I'm a minimalist, so I like plain facades and window opening in one corner. But if the function requires you to not give openings, like the OT walls, then you'll have to do a good composition. You'll have to concentrate on the form as well as what is functionally inside. Now, I have, after so many years, come to a place where I can say the form follows function is not always the case in hospital design. It is 75% of the time, but not 100%. It sometimes so happens that the form should also be in synergy with what is inside. we cannot neglect the form. The form has to look beautiful, serene. And then if it requires for a little bit of molding on the inside, the walls coming in because of the form being curved, let us say, we should do that. Yeah. Okay, so some interior elements in a hospital. A hospital, please do not try to make it a boring place. Some people like it sober. Some clients want it to be mild, mauve or beige colors, but some want it loud. Yeah? Plain colors are very much soothing. So instead of boring browns, to me, a wooden brown is I kind of run from that. I would rather want plain colors. They are soothing, they're continuous. There's a different play. So it is dependent on what kind of liking an architect might also have, because you also still want to make a statement. Yeah? The client may also suggest, so go together. That's it. It's a complicated machinery, but it's fun. Yeah. Thank you. Thank you.